Hello, good afternoon, and it's that time of Monday again, and you're very welcome to week 4. And today we're going to be looking at arrays and strings, and I just want to bring a couple of things to your attention, and so. Okay, so here is where we are in tutors so far. So we've looked at selection and loops, a lot there, and we've looked at methods, and today we're going to look at arrays and strings. Just to mention as well that we now have the first assignment up there, and you can have a look at that. So in essence, a lot of that is there is code available to you. So if the code is available, we'll be asking you to reflect on it and to kind of explain it to us. And if the code isn't there, we're asking you to write it. So just and a spoiler alert, I will be doing a podcast with Laura, which should be ready at the weekend, about the assignment, just to kind of give you some comfort on that. So Sunday the 2nd of November is the handout, which is essentially this day fortnight. So, but you'll have next week. Remember, next week is a lecture-free week, and so on. Okay, so this is what we're going to look at today. And last week we were looking at methods, and methods are really, really important when we're going ahead in anything. It's our way to bundle jobs. So it's about the idea, if you remember the design of the music system, it's about putting all of the CD together, all of the amplifier together, all of the tape deck together. Originally the main reason we wanted methods, we were always talking about reuse in software, and reuse, of course, is very, very, it's very important, and we try not to repeat any code and so on. But actually, there's enough of a benefit in just breaking down a job into smaller pieces and methods, if you like, the reusability of it. So reusing a method a number of times is nearly kind of the second best thing about it. So just to remember that, and to make sure you have. We had a quick look at recursion. A few questions on that the other day. We don't expect you to be experts in recursion. We're kind of showing it to you because it's a beautiful way to solve certain problems, and there will be certain algorithms that later on in your journey you might see solved using recursion. And when it happens, it's one of these things. It's very hard to write something in recursion, but when it happens, it's beautiful. So that's there last week. This week I've just had a look at the assignment there with you, and just to get a quick look at that. And today we're going to look at arrays. So arrays are when we bring in a collection of things together. So our aim when we're writing programs is that we write something for one item, and then we loop that for all of the items. But we're going to look at today why we need a different data structure to do that. And we're going to start with showing you how limited we are at the moment, and then we'll build into the rest of it then. Okay, so off we jolly well go. And primitive arrays. Now, just to note as well, we call these primitive arrays because they're a primitive, the arrays like this are a primitive data type themselves, right? It's not that they only contain primitive data types, okay? So we're going to look, first of all, justify the arrays, and then we're going to look at how we're actually going to solve this kind of. Basically, if we don't have arrays, we either have loops or we have an awful lot of either lost data or an awful lot of variables, and then actually the syntax of that. Okay, so we're going to look at a few pieces of code to explain the concept of why we need the arrays. So in each of these pieces of code, now please don't take the first piece of code and think it's the best code ever. We're going to take one piece of code with loops, one without loops, and then another with arrays, which allows us to have the best of both worlds. In other words, sorry, the second one doesn't have a loop, but it remembers all the data. So in each piece of code, we read in 10 numbers from the keyboard, we add the numbers to each other, and we print out the sum of the numbers. So what we're trying to do is we need to go through all of the 10 numbers and add them all up. Now, if we're adding those numbers up, it would suggest that they're in some way linked, right? But anyway, we don't have them yet, so we'll just go with it. So here's a first possibility. So if you look, I've done the so here, this is all the, if you like, the wrapping around it. I'm setting up the scanner, but this is the main part of it. So I'm reading in, I'm going to read in all the numbers into n, and then I have sum, and that starts at 0. Okay, so I'm going to do this 10 times. So the first time, I'll just go to I. Now there's an I, there's a cunning plan why we're starting at 0, but we'll come back to that. So the first thing we do is we say, please enter a number, and I'm going to actually type in the value of 5 there. Okay, so the next thing that happens is that sum gets the value of 5. Okay, the next value I'm putting in is 10. So the sum is going to be 15. Sorry, and the I now is it's gone to 2 now, and then so on. And I keep going until I get to 10. So at the end, the sum will contain the sum of all the values, all 10 values that I've entered. Okay, in this piece of code. And then at the end, because there's no point in calculating it unless, as we go along, we'll be returning the values, but at the moment, we're just going to print them all out. Okay, so this is kind of nice, because if I needed to change, if I said, oh, got it wrong, and I want to actually read in 20 numbers, the only thing I would have to change here is 20. So it's quite extendable, and it's quite useful like that. Okay, so why can't we just stick with that? The problem here is that we're adding the number, so we're actually adding it now. Remember what that is the same as? That is the same as sum is given the value sum plus n. So every time you read in a number, you're adding it on to sum. So this is our aggregate way of adding something. Just a note there that when it's addition, you start with 0. If that was multiplication, you start with 1. It's the identity, the thing that doesn't make any change. So and the sum is printed to the console. All good so far. Now the only problem is that every time we read in a new value, the old value of n is lost, and it doesn't remember the individual. So at the end of the loop, all that's going to be left is the last number you had, because every single time you overwrite the previous n. So that's not great. And if you that have ever gone in and given your medical details 47 times in the one day, you'll know once is enough to enter data. Okay, so in computing, this is a big thing for us, right? We always try to store input data for later use. Okay, in real life systems, you really nearly always need to use it again. And the thing is, in the few times you don't, if you don't need it again, why are you bringing it in? It doesn't generally make sense. Okay, so we'll try another way. So this time now the benefit of that is that we had this changeable with the loop. We had this changeable thing where we could go from 10 to 20 or 1,000 very, very seamlessly. Okay, the next one, our priority here is that I want to remember the data. So it's you going into the, you go into the hospital and you don't have to repeat everything again because it actually remembers. In the model we were looking at before, it was like the doctor could only remember the very, very last person they had interviewed or taken the case, whatever it's called. Okay, so again you can see here, right, we're looking at same kind of idea, right, except this is essentially what we did in the loop the last time. Okay, and we did that 10 times. But this time we don't want to overwrite the values at the end, so we're going to hang on to them. Okay, very messy, because worst case scenario, somebody comes up and says, oh, by the way, I want 100 numbers, then you need to have 100 variables and so on. But the benefit is that you are actually you're actually remembering the numbers. So what we're going to look at is a way that brings the two of these together. So we have retained the input, but we no longer use loops. Now we can't be going forward without using loops. So we're going to look at arrays, right? And arrays it's a data structure that allows us to group information together in a way that we can use loops with them. So basically we get the best of both worlds. Okay, so when we're looking at arrays here, remember our N1, N2, N3. These were our separate variables in the previous one, right? Our array is going to look like, this is our syntax, but we'll come back to that. This is what it looks like. Instead of having 4, now I've gone from size 10 to 4, but it's clear like this. Okay, so here they were all initialized to 0. Remember, all integer variables get initialized to 0. So now we have a collected piece of data. The name is kind of the same, except in this case we've N1, N2 and 3, but we don't have the capacity, if they're not linked like that, to just say change to 1 and 2. Wouldn't it be nice if we did? So now we have an N here, which is the name of the complete collection, and we have an index to each element, or a position, or indices. Okay, so there's two things there. Now because they're integer, these are the positions, they never change. The values at those positions will, of course, they're variables, so they can. So when I want to access any one of those, I use square brackets that says go into N and give me the 0th element. Now, just deliberately, I've started this as N1. Your arrays are always going to start at 0. Okay, that's basically it's because it holds the address, and you add the size of the element type to get to the next one, so you don't the first element is at the address plus 0, if you know what I mean. Anyway, no need to remember that, but there is method in the madness, and that's why when we're looking at the for loop now, when you're dealing with arrays, you will be going from 0 and less than n. So if there's 4 elements in the array, the indices are going to be from 0 to 4 minus 1. Okay, so just to make sure about that. So you have the indices, the positions, and the values. Now, they don't have any values in them at the moment, but we'll see more about that in a while. Okay. We can access any one of them directly by saying n1 is equal to 36. Now, because up here I have said each one of these elements, I promise you that when we set up n, each one of the elements is an integer, right? There happens to be 4 of them, okay? So anything I can do with an integer variable like over here, I can do with an element, or in this one, of the array. So I can do assignment statements, I can do anything that I can do with an integer, because what they are is a group of integers brought together. A few things that kind of run from that. One of them is that if one of them is an int, they're all ints. If one of them is a boolean, they're all booleans, and so on. So if you have different types that you need to bring together, we need a different structure. But when you have related items, so in this case, they could be, it could be whatever, sales in your different shops. But it's, it could be a student's marks. So just say if you had we'll assume this, so you could have student marks. So just say you're doing, we'll just assume you're doing 3 modules this semester. So we'll say marks 0, 1 and 2, and we'll say the marks that you get at the end of the year, 65, 71 and 52. Okay, so you can see that they're linked. Do you know what I mean? They're from the same idea. Okay. Okay. So this brings us on to the primitive arrays, and what we've actually seen there we'll go through in a little bit more detail. So they're a way to collect associated values. So as I said, if you want to get all the information about one student, it's a different animal. It's actually a class or an object. But if you want to say, I have all these numbers or I have all these strings, for instance, you could describe a sentence as, an array of words, that kind of thing, that they have something in common. And this is this special fixed size collection. Now that's a really important part, fixed size, right? Because from our point of view, we make a decision at the beginning as to what the size of the array is, and after that, for this fixed size collection, we cannot change that. Okay, and we call this array, and it's a primitive array because it's a primitive data type. Okay. So Java arrays can store any primitive types or object types. So primitive ints, object types, string. We'll see more about that later. Any objects you've seen that you've written yourself. Any classes that you've seen, you can have these object types as well. And of course, they have their special syntax. Okay, so what is it? So first of all, I'm going to look at what I call the primitive types. So if I have a number, I have an integer number is equal to 17. So try and think of it from the compiler's point of view. What's the minimum amount of information that it needs to, that this needs to uniquely define this position in memory. Okay, so we need a name. We need to know what type goes into it. Why is that? Because we need to be able to see what size it is. We need to be able to attribute, the different methods that are allowed in that. And then we can give it a value of 16. Now, just for the declaration, you just need that. But, okay. Okay. That's directly stored in memory, just like that. Okay. So what do we do with we're going to look at the arrays. And it's made up of subdivisions or sections. And it looks like this. So this is just going back over what we've just done there. And we'll either kind of write it across or down. Sometimes I kind of get used to writing it down, and I find it kind of handy if I'm someone, but whatever suits. So you could have it like that. We say nums 0, 1, 2, 3, and you can see there a few things that are really important, right? First index is 0. If n is the size of the list, if there's n elements, the last element is n minus 1 because we start at 0. Okay? And we could have it the other way around. Now remember, all here, whoops, they're all integers, they're the indices. These values here, that could be 17, 14, 57, whatever. All the way up through. These will always be 0 to 9. You can't change those. You can change the values that are in here. So if I say, we'll call this A, right? If I say A1 is given to value 50, I would just overwrite that. Put in 50. Okay? Okay. Right. So, structure of a primitive array. Now remember, if we just go back and we say that when, and just say if I said, instead of int num, if I said int, whoops, if I said here, I just did that. When it's created, the default of 0 will go in there. Okay? The default of 0. So every type like that has a default. All right? So the order then, here, what happens here? So just to note that when we do that, we're just declaring the array. Now, remember there's a couple of things going on here, right? We don't know what this is made up of. In general, in an array, and we can call this dynamic memory allocation or whatever, that's a promise that eventually numbers will have an array, okay? So in fact, what happens here is that's going to be an address. Now you don't have to worry about this once it's done, right? But that's the address. If just say that's F4, That's at position FFF4, but you know there's position 0. Yeah? Okay. But to start with, before that happens, the default version of an object is null. Null is a special word. So null is the default for object types. Okay. So when I say numbers equal to new, now I can see what's going to happen here is that now has an address, and that's at the first address there. And just behind the scenes, and you don't need to remember that, but basically there's a little mathematical formula going on that says this is FF4 plus the size of int, yeah? So it's contiguous in memory. Do you know what I mean? So if that starts at that and the size of an int is 2, it's not, but that would go up to FFF6. All right? And that's why we start that. But we don't need to worry about that at all, because we just go, okay, I just call that numbers. Okay? So that's what we think it is, and the other one is what it actually is, right? So, so we've declared an array of integers. That's how we did it. And then we've said it has a capacity of 4. Now remember the new? We've used that in constructors. So new will say, now do it. You know, give me the memory. Allocate the memory for this. Now, a few things. The array is called numbers. We can never change the size of that array or the amount that's allocated from anything. It has to remain at 4. So you can think about it. You get your block. You can't necessarily increase that block because there could be something else in just contiguously after that. You can't be sure. You can't overwrite anything else. So once it's fixed, it's fixed. The other thing is the name. It's any variable name will work there. But what we're trying to do all the time is have our naming convention that makes it really, really nice to understand what's going on. So we had, in the previous one, we had a single number. And we just said int number. All right. And then we had this box called number, one single number, right? If you can describe one of the elements here as a number, then numbers, plural, is a good name for the array. Okay, so all the time, so the kind of the golden rule, the default one is describe one of the elements, like I was saying about student marks. If one of them is a mark, they're going to be called marks. Okay, so remember again, we have a few different conventions that are coming up on the thing. We will see that when we get into object types, apart from the, you know, it's primitive type, but the object types like string, we always have a capital letter. For S or anyone you write yourself. Okay, and that's where we're going with that. Okay. So be sure to differentiate between the index of each array or indices, positions, and the values that are at those positions. Now at the moment they're defaults. Now remember, I've just essentially what I've done here is I've created 4 separate but related integer values or integer boxes in memory. The default for an integer is 0, so you get, remember we had null in the previous one for the null up here, but now it's 0. Okay, we'll see more about that later. Okay, we can directly access any element, we saw that earlier, numbers, square brackets 2. The square bracket says we're talking arrays here. Okay, so it's square brackets. Anything you can do with an ordinary integer variable, you can do with an element of the array. That's the whole point. They're just related. They're grouped together. So you can say numbers 0 is equal to 12. And the beauty of this is that if I was reading in, just say if I was trying to read in a value, and if I said, okay, I'll just say, I might disappear here for a minute. Say numbers 0 is equal to input dot readInt. Then I could say numbers 1 is equal to input. Now you can have your print statements to say enter numbers and so on. Dot readInt. So what you're looking at is repeated code here. And in fact, there's only one thing that changes. And that's this. Okay. And unlike where we had the n0, n1, n2, n3 variables, this is now manageable. This is now parameterizable, if you like. So I can actually say here now, instead of that, I can say for int I is equal to 0, I less than 4, I plus plus, numbers, I'm just going to say num, is that okay? Because I'm running out of space. Okay, so that goes to there. Yeah. So now I have the best of both worlds. Can you see that? Because I now have stored the stuff, the information in the things. I have access to them, and now I can also use a loop. Okay. All good there? Again, we can print any of the separate ones out, and so on. All right. So the next thing we're going to look at is the array syntax. And before that, I will give you a 5-minute break. Okay, so just bear with me now as I set up a timer. And see you in 5 minutes. Thank you. Okay, hello, we're back again, and I'm even on voice this time. So we're going to look at the syntax of arrays at the moment. So now we know why we're doing them and or we're using them, and why when you're practicing arrays, you'll be using an awful lot of loops. That's why we do the two of them together. So we have our int numbers here, which says this is it. Now I think there was some confusion over my awful bad writing there. So I was just saying an example of an address would be FFF4. For some reason that's the one I always do. That's hex. It's just an imaginary one. So I'm just saying we use hex because that's what we use generally for addresses. So yeah, that's what that is. Okay. So here that sets up numbers, and this is how we previously we've done this before. The analogy in the primitive array would be then you'd say a number is given the value 8. Okay. With the primitive array, that's the way we do that when we separate them. And basically we could alternatively do this. Int number is given the value 8. That's going to be the same. And now we need a way to do that in with arrays. Now, one of the reasons we separate them out is the way we structure classes, that we just have the declarations and the constructor, and then we'll have all these. But just for the moment, we're not going to really differentiate them in that way. So you can, in the same way as you had the int number, remember, is given the value 8. That's 8 now as well. You can say int numbers instead of int numbers. You pull that in directly, yeah, and you can do that all. So same idea there. So they're the same. As I say, you would split them up. Kind of the default would be this one, the top one. You split them up if you want to. You split them up if in this case, if you wanted to split them into constructors. Just another thing as well, you can either have the square bracket here or here. We tend to put it there, okay? Because I like to read it as numbers is an integer, is an array of integers. Whichever, either is fine. Okay. Now, before we do that, I just want to mention another way of declaring or defining an array. You could say int, oops, could say int numbers is equal to 4, 17, 23, 46. And that will automatically figure out that there's 4 elements there. Okay. Okay. So this time now, we're going to return to our method. We're going to read in and sum 10 numbers typed from the keyboard. Okay. So we had this. And we were losing this. So we want to upgrade the n, or the numbers, to being an array. To have a look at those there. So the first one is where we instantiate or declare the numbers array. That brings it up into number 10 for us. The next thing we do is we say, right, you've 10 parts. Now we're going to assume in this case that we're going to enter all 10. So in this case, remember we looked at that. We call the scanner input object. Called the scanner input object. So when I is 0, just numbers, we'll just say 0, and this goes down as far as 9. Okay, so the numbers one, just think of a number, 4. When I is 0, sorry, it's this one here, I is 0, so whatever number comes in from that, we've said 4, we'll just go into that. Then I will become 2, and down you, I will become 1, starts at 0, of course, because the first index is 0. All right, now, just bear with me here for a moment. We'll just have a look at that on So I'm just going to show you the code there. Okay, so it's slightly, I'll just make this a bit bigger. Okay, so this is the this here is what we were talking about. So this bit here reads in the now I'm over here now, so I might have gone away a little bit. So that bit reads in. Now I've set 5 because I don't want to we have to eventually finish here, so I don't want to be doing 10. So I'm doing those 5, and then I'm going to sum them up. Okay, so just to see where we are here, I'm just going to say SUT just read in. Okay, so we'll see exactly where we are and so on. Okay, so I'm just going to run this now, and also what I'll do is I'll just make it easier. I'll say SOUT enter number, and we'll go there. So I'll just say run main, and here now that's quite small. I hope you can see it a little bit bigger there. So the first number I'll enter will be 10. Then I'm going to end 20, then 10, then 20, okay, so what happened there? I entered the numbers, so that one went into that number went into numbers 0, numbers 1, numbers 2, numbers 3, and numbers 4. All right. Then this was executed, just read in data. And then we'll go back here a bit. You can see that it starts out with sum is equal to 0. And it starts off then with for int I is equal to, and it sums up the numbers. Okay? Right. So, when you're looking at things like this, okay, what you're looking at is, can I do, so if you like, this loop and this loop here are separate and one after the other, okay? And we've basically two things that we're doing every time, right? We have this line, summing it up and reading in the value. So sometimes this doesn't work, you know, if we have to be careful about doing this. But in this case, we could just lob this thing up here. I'm just going to copy it for the moment. Now, the problem there is I haven't, I didn't have it declared or defined. So I'm actually going to, now I can do an edit there for any of you that are, oh sorry, I can do, in my case it's command, and that will do that. Could do the same for this one actually. So we'll run this one now, and you'll see it all happens at the same time. Go when I say at the same time. So number, and I'll make this bigger again. So we'll say 1, 5, 3, 2, 0. Sum is 11. Okay. So 1 and 5 is 6, and 5 is 11. Okay. And that worked perfectly well. Okay. Right. So just, if I can just look at another kind of one there for you. Right. If I wanted to, I'll just copy that now and leave it for later. We can only have one main, okay, so I'm going to comment that out. Now in this time I want to read in 10, I want to read in 5 values, and I want to print them out in order, okay? So if I do that here, try and do it in the same, I'll just say, sorry, just numbers, okay, all right, so now I'm going to read and see how this works. We don't think it's going to be good, right? Hint, spoiler alert. So enter a number. If I do, what I want to do is I want to be able to read in 1, 4, or 1, 3, 5, and so on, right? So I'll go 1, and you can see it just prints it straight back out of me. So I can't do that in separate ones. So here, if I want to do that, I'll just get rid of that here and put that. If I just want to print them all out again, and I'll just uncomment that then, and we'll see. Okay, I'll run it again. Say 1, 3, 5, 7, 9. Okay, and just another couple of things there. If I wanted to, as well, if I wanted to read them in or print them out backwards, I'd say I starts, remember, at 4. It keeps going while it's greater than or equal to 0, because that's determining, you know, we have a 0. And I minus minus. Okay, so we'll try that. So I'm just going to go 1, again, same numbers. 3, 5, 7, 9. And you can see they're coming back backwards there. Okay. So there are just a few things to mess around with. So sometimes you can, you would hope you can, sometimes, and sometimes I'm not supposed to be that big, excuse me. And sometimes you can't put them together. And you get to use that. So it's just about what you can do in parallel and what you can't do in parallel. Okay, so with that little break from slides and a bit over to code, we'll just move over back to the code. So that's where we finished there, and we were to try it out there. So if you even want to pause and get working with that, just to see how you're doing with that. So really what we want you to be able to do is to read. We're saying read in at the moment. You could use that other defining one where you just put in values and then print them all forward, print them backwards, print every second one, you know, do whatever, or even print ones that are over 10, just print out the values that are over 10. So just, I always think it's just trying to make yourself so bored, it's so easy. That's where we're trying to get to. Not that we're trying to bore you, but you know what I mean. Okay, so this is what I've just done there, right? So you have that in the notes. So because, if you like, this the sequence is okay to do one after the other. Whereas in the other one, because we wanted to print them all out together, we had to have them all done before we printed them out, or all read in before we printed them out together. Okay, and so this is a nicer version. Okay, and that's the one we were just working with there on that. So you have that there for yourself. So again, really important to play around with that and work with that. Now, so what we did here, right, if you look back on this, now we're very particular all the time about talking about fixed size arrays, right? But we can be a little bit more creative with that than you might think. So when we say here, new int 10, okay, what we can do is we can actually have, if I have a variable in there, so just say I had, I'm just going to call it x. If I said x was equal to 10, I could say new int. Now please don't do that, but you know what I mean. A variable will work there as well, as long as I have it declared and defined. Okay, so I'm not going to do that, but what I'm going to do is I'm going to allow the user to read in how many bits of data they have. So here we have our primitive array, the declaration, and then we say, oh, how many do you need? And we read it in, and then immediately we can create the array, or instantiate the array as being of that size. Okay. And then we can do, so what changes there, right? We were at 10 before. So here we just changed the 10 there to num data. So that's much more flexible, isn't it? So you get to choose, and you get to choose how many numbers. Okay? Get to choose how many numbers, which is really important as well. Because remember, once you have decided it's 6 or 10, you can't change that during the running of the program. Okay. So what kind of data can be stored in a primitive array? So any kind. You can say int, byte and characters, with of course the caveat that once one of them is an integer, they're all integers. Once one of them is a byte, they're all bytes. And you can create them all like this or instantiate them all like this. Okay. So, sorry, the difference there, if it's not immediately obvious, is that we have here, and we have them here instead. Yeah. I tend to use this one, but it's a matter of style, really. Really, I suppose the main thing is to have it there somewhere and to do the same thing all the time so you're not mixing yourself up. Object types. We have a very good example of an object type would be if we had loads of words. So we had a sentence or a paragraph and you wanted to parse the paragraph for some other reason, and you wanted to make a list of words. So what you're saying here is that we're going to look at a string is a great one, right, to look at because it's been written by somebody else, but you have a whole load of words, and actually we know we're going to have 30 of them. So each one of those elements will be a string, and the string could be Joe, next one will be blogs, next one with is, and so on. So for some reason it has, and we'll assume they're all stripped of blanks and all that. Okay, so and the new bank account, that's the one we're writing ourselves, and it's one that you can see the difference between string and bank account. Somebody else wrote string for us and gave it to us for nothing. Bank account is our own, but we're going to deal with it in the very same way, except that we don't trust bank account as much as we trust strings, and that's not a comment on the banking sector's comment on our software. Okay, so again, you can have the same idea here. You can have them here. Oh yeah, they're in the same string words. Oh yeah, they're at the end or they're at the beginning. Yeah? Okay, same idea. Right. Now, do we have to use all the elements in the array? So, up to now, okay, to now we had I'm just going to call this nums here, all right, and I'll just say 0 to 9, all right, and so we might have something like people are going to come in and enter the number, their favorite number, just say, and you have set it up for 10 slots, yeah, but only 7 people turn up. Now we'll just say something ridiculous like okay, so we'll say 17, 18, 9, 6, okay, and the other ones then have 0 because they were defaulted at that, but only 7 turn up. Okay, so we're left now, if I do if my 35, 44 and 50, so the sum of those is 50, right? Now if I want to get the average, the question is, should the average be over 7 or over 10? Because if I go through all of that, it's going to be 50 divided by 10, which is 5. And if I go through the system, 50 divided by 7 is 7.1 or whatever. So this is what we want to do. We want to do the average on just these ones. So what does that leave us? We have our 10. We know that there's 10 elements available to us. We need another variable, right? We have a thing called the list being populated. And that means that a value was put into it apart from the default value. So a value was read in or assigned in or some way. So we have another variable that tells us how big is the population. Okay, so if we know the 7 there, we should be dividing by 7. Not alone that, but we should only be adding up the first 7. 0 to 6, okay, first 7. Okay, so we'll have a look at how we're going to deal with that then. So this is the thing about the logic, you know, if you divide by 10, you're going to get, you know, it'll work. In other words, the syntax is okay, but you're dividing by the wrong amount. So we have a class of 15 students. They have a test coming up and we want to store the array and then find the average result. So this is the original one. With 15, we're waiting for 15 students to come in, but only 12 students sat the exam. The results were recorded in the first 12 elements, 0 to 11. So we want to calculate the average result. We want to divide by 12, not 15. Okay. So if they're not all populated, that's a kind of a system thing, you know, that's we'll know that whether you're saying, tell me how many pieces of data you want. We need an extra variable, this extra variable that tells us how populated, and we'll always assume we're starting at the start. So that contains the number of the elements in the array that are actually used. We ensure that the size is used when processing the array. And then move on from that. Okay, so in summary, we can store any type. Really important that the indices go from 0 to size -1. And to declare the arrays, you need to kind of get used to that, okay? And we have different ways of doing it. Okay. And this is a really nice way, if you kind of remember no other slide apart from that, that will bring it all together for you. Okay. So, just give me a moment there. Okay, I'll just give you 5 minutes and I'll come back and I'll do something on strings there for you. And I will talk to you then. I'll just put the timer on for 7 minutes this time, I think. Right. How you doing? Some really good questions in there. So I might just take this opportunity to kind of answer some of the questions. So what? So the question, really good question. What can we do with arrays? And the answer is anything we do, we have to do ourselves. Okay. In other words, we have to code it particularly. So later on in the semester, very soon actually, because everything is very soon this semester, we will be building a thing called array lists, and in that case it's like string. You get the methods that will allow you to remove and sort and do all those kind of things. For the arrays, what you have is what you're seeing there, like it's literally so just hold on there now, just want to okay, so what you're looking at is just being able to, okay, so we have our, we'll say array A. I'm going to assume for the sake of this that it's an array of size 4, or sorry, 5, that's the whole point, 0 to 4. And okay, so if just say I have 10, 15, 20, just say 25 and 30 here. And okay, so really all I can do, and just say I have int size here, right? Now switch off if you need to go for a cup of coffee, because this is just, if I want to remove this element here, all right, what I actually have to do is I have to move up each of those. Now when I say manually, I mean, you know, you'll have an if statement or a loop that goes back until you get to the one that's been overwritten, and then size will go minus minus as well. Okay, so what I'm saying is we have to absolutely code everything about the arrays. Why are we doing them? We're doing them because you need to see that kind of traversing of arrays and so on. And then when we move on to the array list, you kind of know what's going on in a way, and you'll appreciate what's going on, and so on. Just say for delete, sorry, that's delete. If I wanted to insert one, I'd have to kind of do the opposite, move them down until I found a place to, you know. So we will be looking at that, and those algorithms are very important, and you know, you'll see them later on when you're talking a little bit more about, I suppose, algorithmics as such, that how you actually do all those. And it's really nice. It's actually a really nice area, because you're kind of getting into the guts of it and over and back and so on. And the sort. Okay, so the next question then is, another very good question is, because I never thought of mentioning it, but basically, Dara, you were saying that if I had, you know, this idea of 0, we'll just say to 19 here, okay, and I only went as far as, we'll just say 9, okay, how would we know which ones to disregard? The whole point there is we populate from the, and this is kind of more what I'm saying, we populate from the top down, okay? So we're actually going to go, if I know how many, now we haven't fully designed how we'll do this, just say I know it's I'd say AI is given the value input. Okay. So, and then I know that 10 is the amount, and I can do the summation on that. When we're looking at fixed size arrays, we either, you know, have a thing called a parallel. Now this is you don't need to worry about this, but unless you had like a parallel array here where element 2 is the student number and you want to do things like that. But in general, we're going to put them in one by one, and then we'll always know, when we know the size, and that's the name of the thing, we always know that the populated part of it is 0 to size minus 1. Okay? Okay, so Dara, I just see you're typing there. I'm in a very slow Wi-Fi here, so it might take me a while to get there. Okay? But does that make sense to people? Or is there another? Okay. Okay. So just while we're... Okay, I'll just wait for Darius to come in there. Okay, so yeah, sorry, if we wanted to link every student, like we're trying to do the very basics here, Dara, right? So we're not trying to link every student. Sorry to read out that. In a case where we do need to link each student to an ID, essentially what we'd have there is, okay, so if I'm, just want to rub this out then. So we'll just get rid of this. So we'll assume that they're all, that the values are populated. Okay, so didn't want too many there. Not clever. Okay. So just say I had a student's average mark, we'll say. So I'm assuming these are just each student's average mark. So we'll just say that's 50, 45, 72. Let's make this smaller. 53, 62, 100, 1, 2, 3, 4, 5, 6, 7. Okay, so they're the marks, the average marks. What you could have is a parallel array here. Now this is just using arrays, okay, but that's not the way we'll do it. But it is a nice way, and I always think it's a really nice algorithmic thing as well. So we'll just say this is student numbers. So that could be the, I'm putting the index at different sides, so this could be 201. I don't know whether I should be mentioning student numbers. It's not a great, have you got your student numbers, folks? So you can see that, and in that case, you know, you'd have that there, okay? Now I hope that makes sense. However, what you would actually do in that case, all right, is you'd have a thing called student class, and in the student class you'd have student number, you'd have, I'll just call it an int of an average, yeah. Your methods down there, and then you'd have down here, you'd have student, I'll call it computer science because that's, and I'll say there's new student. Okay, and in there then you would have, just get rid of myself, there then you would have there you would have the connection then is different. The connection is within the student itself. But the parallel arrays would have been very, very useful, and they're very, very quick, obviously. And in fact, I have an animation that I'll have ready that does the parallel arrays for things like CSV files and all that, just to give you a look at that. All right. All good. And in fact, if you just bear with me, now please, for any that's kind of just keeping up, just ignore this, right? But just bear with me there. No, I don't have it. I actually don't have it with me. So, okay. So I think we'll leave it off. We'll No. Thanks, Dara's saying there. Sorry if derailed the lecture. That's a really, really good point. And like those questions and Maureen as well, it's really, really good because it brings things together. And questions like that, if they're individual and they wouldn't add to it, I won't answer it in class. So never worry about that. Always ask, and it's much nicer to be answering a question like that, as long as you know that if those that are doing programming for the first time, don't worry if what I've done, that part of it doesn't make sense, maybe before the break. So much so. Okay. So we'll see you again on Wednesday. Bet you can't wait. And we'll be going on to strings and so on. And remember, just have a look at the assignment that's there as well. Okay, so I think Siobhan might put in a Zoom, or we'll put in a Zoom link there if anybody has any questions. And we'll be on Zoom maybe until about 2, if that suits, to be 2 of us on it. Okay, so thanks a million. All okay there? Any more questions before I leave? No. Okay, so see you on Wednesday. Thank you very much.